In this example, what we're going to do is we're going to practice finding reference angles of triangles. I had a video that was directly correlated to finding reference angles in any quadrant, first, second, third, and fourth. This is just 3 practice problems that will help us articulate, hopefully a little more clearly, about what reference angles are. So, in the first one is 5 pi fourths. Whenever I see radians, in my mind, I'm going to be converting into, that's 5 of these pi fourths, and I know pi fourths is 45. That means I've got 5 of those 45s. So if I have 5 45-degree angles, there's 2 of them, there's 4 of them, because 2 45s make a 90. Then I need to be another 45 past there. There's 5 45-degree angles. So here is a picture of the angle. If we want a 5 pi fourths, it would go all the way around, starting on the positive x-axis, the initial side. Here's 5 pi fourths, which is equivalent to 225-degree angle. So if we want to find the reference angle, remember reference angles are always drawn from the terminal side where it hits the unit circle, or this circle that I have drawn. Go back up to your x-axis and then figure out what this reference angle is in here. Now if it's in the third quadrant, since that's the one we're in, we always want to figure out how far past, in this case, pi we went. How many radians past pi did we go? So we're going to take our 5 pi fourths and subtract pi. But in order to work with these fractions, we've got to get used to dealing with common denominators. So that's 4 fourths pi. So we have gone 45 degrees, or in this case, pi fourths degrees beyond pi. So our reference angle sitting in here is pi fourths. Now that's what they're asking us to do. Sketch the angle and then find its reference angle. I sketched the angle. Here's the reference angle that we're going to use in radians. Okay, so next one. Negative 240-degree angles. Degrees. Go negative 240. So there's 90. There's 180. Okay, if I go up to here, that'd be 270. I don't want to go that far. So I'm going to go in here and I'm going to park that angle somewhere in there. And I'm going to stop. And I'm going to say, okay, that is a negative 240 degrees. Now, when we work this thing backwards as we did, we want to know how far past 180 degrees we went. Because we rotated 180 degrees negative in this direction. So now, what is our reference angle sitting right in here? Well, if we want to figure that out, what we'll do is I'm going to just stay at 240 degrees. And I know it's negative at 240. I'm going to subtract 180. Because that's how many degrees past the 180 mark that we went, which is going to be 60 degrees. So the reference angle that's sitting in here is a 60-degree reference angle. So what we would use is a 60-degree angle in this reference triangle to find all of our trig ratios. So our angle is drawn and our reference angle is 60 degrees. And the last one, 390 degrees. Now 390 degrees is going to be one full rotation around, that's 360. And then we've got to go another 30 degrees beyond that. So since we're in the first quadrant angles are always the easiest, because once you're in the first quadrant, this 30-degree angle is your reference angle. The whole thing was 390. Our reference angle is 30 degrees. Okay? Reference angles are always drawn to the x-axis. It's always what's remaining, either out of 360 or 180. So you're always subtracting to and from 360 or 180. Done with those.